Okay, so this is going to be the last session before the lunch break. We'll be talking about building information models. And let's start this session with a polling question. So ladies and gentlemen, phones out, and let's take a look at the upcoming poll question. So I would love to know what your take on this one is. So when it comes to building information model, what do you see as the biggest challenge in managing large estates? Too much focus on geometry, not enough on information, lack of consistency, metadata standards, difficulty scaling processes across sites, or limited integration with facility management needs. So let's take a look at your opinion on this topic. Okay, so the votes are coming in. Too much focus, lack of consistent metadata. Okay, we've got a split over here, almost an equal split. So let's wait for a few more options and a few more votes. And then I'm just going to introduce the next speaker up on stage. Perfect. 26 votes in. So too much focus on geometry. And actually that's going to be at the core of the upcoming talk. Challenging the notion, so too much focus on geometry, not enough on information. Perfect. Almost 50% of you sees this as the biggest challenge in managing large estates. Perfect. Well, in the upcoming session, as I already said, we'll see why information-rich BIM models are more powerful than geometry alone, and how metadata unlocks smarter decision across large estates. Ladies and gentlemen, please welcome the founder and managing director at Building Spatial Intelligence, Jeremy Pilgrim. Let's give it up for him.
Welcome, Jeremy. Okay, well, thank you all for attending. My name's Jeremy Pilgrim. I run a small company in Lancashire in the UK. Anybody else in from the UK? Oh, right, okay, so I need to translate all of my references so that they work stateside. So as a company, we are very clear on our lane where we live. We are a Scan-to-BIM company, and I say at scale. We all know what Scan-to-BIM is, but what is at scale? There's many different measures. Looking at the Everett facility in Seattle for Boeing, I've been there. It is massive. We're not at that scale. Our scale is more to do with the number of properties that we're working with. So we, as a company, focus on schools in the UK. So I think we've done about 4,500 schools where we've collected detailed site data, drawn floor plans with structured data sets extracted from those. And more recently, we're up to, I think, about 400 3D models of the schools. The data that we collect is always highly structured data, and we have a focus on the words rather than the lines in the plans. So I always say that when you look at a floor plan of a building, you've got two things that you can see. You can see the lines, you can see the words. I don't think the lines are anywhere near as important as the words. The words have all the value. All the lines do is give context to the words. And that's pretty much the basis of what we do. So for my sins, I've been in this industry for an awful long time. If I go back to, I don't want to be too precise, but the 2nd of November 1987, I bought my first computer, an 8086 processor. I think I got about 256K of RAM. But I learned a phrase then that I hate these days, and that's future-proofing. I had an option between a 8 megabyte, 11 megabyte, or 20 megabyte hard drive, and I went for the 20 megabyte hard drive, so I would never have to buy a hard drive again in my life. That's how visionary I can be. Back in 1988, I think we were exhibiting the first scanner in the UK. Yes, it was only a 2D paper scanner, but that's the beast that you can see on screen there. And there's the internals of it. It used to take about 2 days to calibrate with a man with an oscilloscope working on it. I think it was about $90,000 to buy, $150,000 for the workstation to run it. Oh, and then you're going to need some software to do anything with it, and that's going to be another $30,000. But what a brilliant piece of kit. People were queuing up 3 deep in the aisles at the events we were at to see this, because it was just amazing, the technology of what we were doing. And in a lot of cases, what we were doing there is more accurate than many paper scanners today, because it was all about absolutely perfect dimensional accuracy coming out of that scanner. At that time, we did a lot of raster-to-vector conversion. That was something close to my heart, in that worked in the drawing office. It was interesting to see Bradley's presentation just a couple of presentations back, where he showed the pictures of the drawing office. I was in the drawing office. I worked a drawing board, and I was there a week before I left when we brought the first CAD systems in to the drawing office. They had a huge air-conditioned room, specialist lighting, nicely darkened, 2 tiny little workstations for drawing. But that was something I was quite passionate about. And the systems that we were using back then with the scanning was all to get the data into a structured form in 2D CAD. And we used a lot of automated raster-to-vector. I was very familiar with the phrase electronic spaghetti, because sometimes that's what you get out of it. And even to this day, I still see some clever AI systems giving me electronic spaghetti and what they're trying to interpret on conversions. Back in the mid-90s, I can't remember the exact year, but I think it was around 95, I was first introduced to 3D scanning using the Mensi system. I think it was about 100 points a second and about a 10-meter range. We had, in every scan, we had to put 3 huge red soccer balls for you guys, that on little tripods. And those 3 soccer balls had to appear in every scan so that we could register them together. Working in SLAM these days, I sometimes look back to those days and think I would like to have some of those nice big red soccer balls around some of the sites that I do, because they'd come in very handy. So I started working on large volume projects in about 1995. It was a project for Somerset County Council in the UK. They ran, I think, about 300 schools in the area, and they had a very visionary man running their school estate. He was the chief surveyor, very old school, didn't know which way up a computer went, never mind where to turn it on. But he had a vision of what he wanted to try and achieve with this, and I got the contract to take his hard copy drawings of all the floor plans of the schools, and he didn't just want unstructured pictures creating, although we didn't know these terms back then. What he wanted was a database to come out of those drawings, and he couldn't tell me in computer terms what he wanted. He just knew he wanted a database to come out of the drawings, and he wanted highly structured data to come out of those drawings, and that's what we built for him. We scanned the drawings, we traced them into CAD, and built a highly structured data set on top, so that he could identify any of his rooms, he could identify any of the elements of his buildings, he could identify the assets within his buildings, and he could start to manage them through a computer system. Now, a stroke of luck was that the guy who I worked for, Bob Baber, was moved to do some standards for the new UK government back in 1997. I don't know if any of you in this audience would recognise that guy, but we elected him in 97. I think he wanted to be president, but we only allowed him to be prime minister. And his job, his election pledge to all of us was education, education, education. That's all he wanted to focus on. And he had a particular focus on school buildings. They were in terrible condition at that point, very poor investment, lack of investment over the years, and he's wanted to focus on how to get good quality data about the school buildings. And he came up with 3 simple tests of condition, sufficiency, and suitability to measure every space in every building, of every school building, across the country. So condition, an easy one from a defects point of view. What's the physical condition of the building and of the rooms? The sufficiency, is it sufficient to teach? So a simple rule of thumb, 56 square meters, you could teach 30 children. Then moving on to suitability, what's the environment like? safe from a health and safety point of view? What's the equipment like in the room? But also, is the sufficient space suitable to teach? So 56 square meters can be 56 meters long, 1 meter wide, and that's not suitable for teaching. Back in the late 90s, I was heavily involved in GIS in a big project for the local utility company to map all of their underground assets into GIS. My particular role in that was for the quality control. So we were doing all the digitisation in Singapore, and I ran a project to do 42,000 man hours of QC on that, but also with some very clever automated logic testing of the connectivity of the data. But what we brought in at that time was, again, looking at the data that we'd captured, getting that data as correct as we possibly could and as complete as we possibly could. And we employed some, they're actually American standards. It was at the time the American Mill Standard 105, and it was based on Dodge-Romic tables for acceptance sampling of a mass-produced product. So it was designed for a production line where you're producing cars or widgets or anything mechanical, to be able to sample that data, statistically sample it, to say which batches were good and which were bad. And we adapted those to data and to test, was our data to the standards that we wanted? So that's me back, I think, in the mid-90s, and that's two of my senior members of staff now, which happen to be my children, and they've lived and breathed this industry for an awful long time, and they can still cite some of my sales pitches to customers for me. So when we set out, we started off with reality capture, although it wasn't known as that at the time, to get the school buildings into CAD in a structured form. So we were using the Leica distos, which at that stage were about the size and weight of a house brick, and we were using clipboards with one A4 page per room. So we would draw the shape of the room, put the dimensions on, boxes on the bottom for the metadata and attributes. Very similar to what we do today, except on a computer, but it was just all done manually. We took 4 photos per room with a digital camera and put the photo numbers off the tiny little screen on the back of the camera onto the sketch, with a direction arrow showing you which way the camera was pointing when it took the photo. And on one particular project, I know for Gloucestershire County Council, we did 450 schools. We took 160,000 photos. So those sketches came back to the office, scanned, sent to the back office in India. 160,000 photos on multiple digital cameras, on multiple cards, came back into the office, transferred to India, and had to be matched to every hyperlink in every CAD plan to be able to see those photos. So processing large volumes of data and getting it right has been something that's been a passion of mine for years. Luckily, Apple came along with the iPad, I think, in about 2012, and from then on, we could start to draw in a much more efficient way. Leica had got a disto that was actually easy to hold in the hand and had Bluetooth to the iPad, so we could now start to not write the dimensions down. We could actually click, draw a line, and start to build the buildings electronically from that. We went paperless at that point, which was an interesting exercise. That the company, I just wouldn't have any paper in there, no printers, and we've been paperless ever since. It had a couple of interesting times when we were hot desking in the office. We had no paper, everybody was on laptops. When we left, the office looked like it had been abandoned, and I did get a call from the landlord one night wondering if we had actually done that. So lockdown, difficult time for us all, 2020. I took the opportunity, after I'd done everything that we all did, to look at my business and try and figure out where do we go from here. And I started looking back at scanning. What are we doing with scanning? Could I do 3D scanning for buildings for 2D? And then could I start to look at 3D? One of the key factors that I've always maintained as we're doing the work that we're doing is the throughput rates to meet the price and to understand the process that we're actually doing. So we did a job for Hertfordshire County Council, 550 schools. about a million square meters. So I think that translates to about 10 million square feet of schools. But in those schools, there were 105,000 rooms. And we'd estimated with our process at that time that it was going to take about 6 minutes per room to do everything, to draw the shape, take the measurements, record the attributes, take the photos, record everything, move on. If you added 1 minute per room to my 105,000 rooms, that equated to about 1.33 man years of extra work. So it's really vital that when you're doing a project like that, that you keep an eye on how long it takes to do things. So as I start to look at scanners and look at 3D scanning of the buildings, the first thing I'm looking at is the speed. So 5 years ago, I think the RTC 360 was the first scanner I looked at, but it was 3 minutes a scan. And 3 minutes a scan was too much with all the other things that we had to do in every space. And to speed it up, you had to compromise on the data that you collected, which wasn't good enough. And eventually I came to the conclusion that SLAM was the way forward. I purchased one of the first bit like a BLK to go scanners in the UK and still using them today. Love them. They're great devices. I think Leica did tell me a few years back that we were scanning more with that scanner than anybody else because we were using it to do full buildings. I wanted to test the outer envelope of what I could do with it during lockdown. I took a BLK to go into a 15,000 square meter school and scanned the entire building in one day. And the next day, I stitched the data together into one point cloud in one day. So in 2 days, I've got 15,000 square meters of data, including some linear control on long dimensions just to check for drift in my scans. So I wouldn't recommend anybody did that. It's not the best way forward in terms of it took about 8 hours. I didn't stop. I kept going. The building was empty. There were no children in it. I had one key that opened every door in the building, and there was only me and one other person in there because it was lockdown. So it was a perfect situation to test the outer limits of it. But using SLAM has brought me pain, heartache, late nights. It's processing the data, seeing some of the strange things that happen. Just you get banana-shaped scans, you get drift that is just incredible as to how it ever got there. You get all sorts of strange things happening. But when you're used to it, you've built a process, you're checking for these things. Superb technology, works great, really good for what we do. As a company, we're very focused on data. We preach a message to our customers about managing their data, managing their buildings using tools such as Power BI to visualize everything that they're doing. Yeah, I sat in my office a couple of weeks ago and I was putting this presentation together and I looked up at the board, a whiteboard with little magnetic squares for every school that we're currently processing. I think there's about 120 on there in terms of the number of schools. I think there's another 30 that have been added to the board since. But we moved them across the stages manually because it's the only way with all of the team to see everything. Somebody then sits down after the meeting and replicates all of this into Monday.com so that we've got a clear picture in a system. But sometimes the old ways are the best. Stand everybody up in front of a Kanban board and work the process through. Make sure you're looking at every area of it, everything that needs doing. We use BIM. I don't like the phrase BIM for what we do with it. Yes, we use Revit to draft the models, but we're not using it as a design tool. We're not using it as a digital twin. It looks like a digital twin. It can be a digital twin, but I tend to call it a digital looky-likey just so that it doesn't get into the conversation about what a digital twin is. But we're using it as a three-dimensional spatial database. What I'm seeking is everything to be referenced. So one of the presentations was talking about breaking down data silos. I don't think we break down data silos. I think we connect data silos so that they're not a problem as a silo. I don't think we can get away from data silos. You go to your accountant and ask them to open up their accounts data for the capital assets in the accounts data to connect to an estates system. You're not going to get anywhere. They're not going to convert their system into yours and get rid of a silo of data. The only way is to connect the two. Now, I've looked at many ways of doing this over the years. A simple thing, let's say we've got a door. Is that door a fire door? When was it inspected? Has it had some health and safety issues? Is the glass in it? Is the glass to standard? We want to know a lot about a door. So we tend to put a barcode on it or a QR code on it, and we scan it to get to the data about the door. But I work in schools, and I work in secondary schools, or high schools in American terms, where there are teenagers. Teenagers love nothing more than to peel barcodes off and discard them or move them and swap them. It's a game. It's actually an entertaining game for us because it keeps us sharp on how to manage it. But if I draw a model of a school and I draw it at the correct place in the real world, to the correct size in the real world, the right orientation and the right elevation, that door is the only door in the universe with those coordinates. So why do I need to put a tag on it to know which one it is? It's a simple principle, but we're at the point now with mobile technology where I can point my phone at the door and it knows which door I'm talking about, and I can click on it and jump through to all my different systems. So yes, we've got siloed data, but the space reference of everything, where it actually is, what it is, and its reference bridges all silos. I think sometimes I look at what my job is, and I think I've spent the last 30 years of my life working on one column in lots of different spreadsheets, and that column is the reference column. It's a physical asset, it needs a reference, but all the systems have that reference to the physical asset, and all I've done is create it in many different systems. So we're trying to use BIM for that purpose. Now, our methodology is quite a simple one. It's very same as what a lot of you are doing in this building. But the key bit that we're trying to do is to democratize the data and get it in front of everybody who needs it for their decisions. And a simple thing we're trying to do there is, rather than using a specialist platform for the data, we're putting the data where they are. And people who are making data-driven decisions are typically in the Power BI world and looking at it in Power BI. So we want to put the model into Power BI so that they can see the data there. And from there, they can start to make their empowered decisions. So, oops. I don't know, I'll make the video play. No. I've got a lovely video for you, but don't know how to make it play. Anyway, what the video was going to show you is the data within Power BI. So what we've done is we're using the format in Power BI for putting graphics, and it's basically what you use for a chart. You can put a 3D chart into Power BI and you can rotate it around. So why can't I put a 3D model into Power BI and rotate it around? If I've got a query that I'm running and I want to see, tell me where all my classrooms are in this school. Yes, I'll get a list. I can do that in Excel. I can do that in lots of systems. But if I see a list and bang, it just lights up where the classrooms are in the school, I'm starting to visualize my data. So if I've got a data source that says, where have my accidents been in this school? Where are my little hotspots? Where do I need to focus to fix things? I can feed that data into the same system, and I can color up the rooms by where the accidents are happening. I can merge any data sets and start to see them together in the same place. So if I've got Legionella data, I've got asbestos data, I've got condition data, I've got cleaning information, I've got the help desk information, I can put all of that information at the same time onto Power BI, and I can move slider bars around, as you would have seen on the video, to be able to see which is most important to me and where are those issues within my buildings. At the Digital Twin conference that was run by RCN, excellent conference in Orlando, I learned something really new that I hadn't thought about before, that I'd done a lot of GIS work back in the late 90s and early 2000s, but I'd stopped looking at GIS because I was inside the buildings, they were outside the buildings, and therefore the data didn't really cross over. And I was watching a presentation by, I think it was Mark Goldman from Esri, and he was suddenly, I saw Esri are within the buildings. Now we're doing indoor mapping, and I'd seen it, but not really taken note of it. And what they're doing in terms of emergency preparation, with the floor plans, getting them to the right place, making sure they've got all the plans built around the plans of what to do in an incident, built around that data, because all of our data from day one was drawn to the right place in the real world at the right scale. It just dropped straight into GIS, and some of these systems work very well with it. So that was an interesting thing from my perspective in terms of what we can do with these data sets from the same set of data. Now, there might be some of you in the room are thinking, everything he said we can do from a classified mesh. We could reference all these objects within the building from there. And you're correct, yeah, you can. It's not as smooth to work with. It's a little bit clunky in some cases, but what you can't do with your classified mesh is detailed thermal analysis. So we're all trying to improve the carbon performance of our buildings. We're trying to improve the energy performance of our buildings, because we're all aware that energy is a finite resource and we've got to work on that. So if we can start to model the buildings, we can start to look at where we go next. Because you're doing an energy project, you're going to start looking at PV, let's put some solar on the roof, let's look at LED, and those are our two big hitters. Those are going to get us the biggest return on our investment for improving the performance of the buildings. But where do you go from there? What's next? Are you going to insulate the walls, insulate the roofs, improve the windows, change the windows? What are you going to do? So by having the model in a very simplistic form in a thermal analysis piece of software, I use a piece of software called ArchiWizard, very simple to use. When I did thermal analysis of buildings, it was at college and we didn't have spreadsheets then. So it was a very different world to doing the thermal analysis today. In that software, I can drop a solar panel out of a manufacturer's catalogue onto a roof, rotate it around, and watch the change in the energy use intensity for that building live as I rotate my solar panel around. So it's got to a very detailed level, and it just got me thinking, what if I put a very poor performing but very cheap window into a school? So I did a quick analysis that you can see on the graph here of any consultant you go to would say, use that window. That's the best thermally performing window. But this one is single glazed, it's very cheap, costs the same amount to fit, but it's half the cost of the high performing window. So because in my software, I can roll the climate forward, in 2050, the south of the UK is going to have the same climate as the south of France. Now, it's not going to happen on December the 31st, 2049. It's a gradual process. So there's going to be a point at where we need to lose heat out of the building, not keep heat in the building. And if that's the case, my single glazed window is going to perform better for some of the life of this building than it is than the double glazed window. So I just ran a quick scenario to test it in the software just to see what it came out with. And yeah, there is a point in 16 years' time where it is cheaper for my single glazed window up till then, but beyond there, it starts to change. But having your own model, data that you own, in a very simplistic form that you can analyze in a very simplistic way, is a very powerful tool to the users, and it's free data almost because you bought it for FM. In the UK, we have Department for Education runs all the schools in the country. Have you still got one in the US? Last time I was here, the first buddy was talking about getting rid of it, but I think you still have. But they've recently started to look at exactly what we're doing here with using BIM as a three-dimensional database to manage the entire estate so that everything is all in the same format, so that they can work together with actually looking at what they need to do on the school buildings to improve the performance. As somebody mentioned on the presentation this morning, the population of the world is falling, and it's falling rapidly. It's against what we thought it would do, but it's falling very rapidly across the world, and I think it's as bad in the US as it is in the UK. But that means we need less school places. So what are we going to do with the school buildings? Well, we've got the models, we can start to analyze it and we can start to work through it. So what we've started to produce with the help of the Department for Education is what we call a minimum viable data set. They're broke, they're government, they're running schools, they're not the flavour of the month at the moment. So they've got to spend their money smartly to get the answers that they want out of that data. So we've come up with this minimum viable data set that gets them what they want at a price that they can afford for all of the schools across the country. So we're trying to look at the data side of this, not the lines and the geometry. We want to get maximum value for the FM out of the data set that we're producing. Slightly tongue-in-cheek graphic that I put in there, but it's an example of many years ago, I mentioned about Hertfordshire County Council. They've got more than 500 schools. About 150 of those schools have got swimming pools in them. And we got a panic phone call from the customer saying, you collected all this data, we need to identify a certain type of swimming pool because there's a big health and safety problem with it, and we don't know where they are. Have you got it in your data set? And I said, this is the query that I'm made for. Yes, I'll sort it for you. And I went to my incredibly clever data analyst, knew everything about data, spoke data, couldn't talk to humans, but he could talk to data. And I asked him, can you just get me a query that gets all of the photos linked into a spreadsheet so I can click on the school name and hyperlink straight through to the photos for that school? It should be dead easy to do. And he came back to me with a very sour face an hour later and said, we haven't taken a single photo of any swimming pool in any school, not a single one. Oh, that cannot be the case. Luckily, I had a man sat in the room who knew nothing about data. And he said, give me 10 minutes. And he came back and he gave me my Excel spreadsheet with 150 schools and hyperlinked photographs for all 150 schools, 4 photos of every swimming pool that we could send to the customer. The simple thing that had happened there is the clever guy looked at the plans, he looked at the polygon for the swimming pool, sort out every photo symbol within that polygon, and there weren't any. The guy who didn't know data looked and thought, right, we take photos of swimming pools, not in swimming pools, so the photos are going to be on the walkway around the outside, and he ran a query for the room to see how many photos of swimming pools there were in the room, and identified all the data. Now that is a very valuable lesson from my perspective, because what it's telling me is I've got all the right data, I'm just asking it the wrong question. And I think that's a challenge we all face with AI, asking it the right question to get the correct answer back from it. So that's pretty much me from my presentation. It's a simple message of the data, I believe, should always take precedence over the geometry. The value is in the words. The lines just give context to the words. Thank you.
Ladies and gentlemen, Jeremy Pilgrim. Jeremy, thank you so much.
Thank you.
You got plenty of questions from the audience. Let's take at least one. So let's get them up on screen. So John is asking, I like the idea of using geolocation for FM/BIM data, but how do you take into account elevations or lack of service in basements?
You can't. It depends on very much on the software that you're using. Is it offline? Is it not? We are, as a company, we're data capture people. We focus on collecting the data, getting the data into structure the customer wants. We are system agnostic in terms of where the data goes. So using it is something we will work very heavily with them on to make sure they've got the right system to manage that data. But yeah, we can't solve that, I'm afraid, in all cases.
Got it. We'll be talking about the bottlenecks in the next question. So what's the biggest bottleneck you see today in scaling reality capture programs? Is it technology, training, or client adoption?
I think client adoption's coming, and it's coming fast because they're seeing the benefits. Everybody wants data because then they can play with AI once they've got some data. The technology, I don't think there's a day goes past without some brand spanking new technology going across my desk that will transform my business. And half of my job is sorting through that and deciding which ones I need to look more at and which ones I don't. So the technology is coming fast and hard. We're in the same arena as gaming, and gaming's big business. It's bigger than the film industry. So they're investing in this. We're reaping the benefits of their investment. So it's happening very, very fast. So I think it's just everything coming together at once, really, is the answer.
Well, thank you so much, ladies and gentlemen. Jeremy Pilgrim, let's give it up for him one more time. Thank you so much.
Thank you.